Welcome all. At the outset, I thank you all for honoring these YouTube classes. And I'm trying my level best to deliver the best quality. These videos will definitely help you crack interview questions. And I'm trying my level best to explain each and everything in a very detailed manner. So definitely in coming days, I'm coming up with many more such videos. So in this video, I'm going to discuss what exactly is wet bulb temperature and what is relative humidity. So in in a short time, I'll try to give you a beautiful concept of wet bulb temperature and relative humidity. You know, my dear students, first let us focus on wet bulb temperature. Later on, we'll focus on relative humidity. So there are two parts. One is wet bulb and other is relative humidity. So forget about wet bulb temperature. So generally what we see in papers or on TV channels, we'll see the temperature is so and so. At a particular place, the temperature is about 30 degrees centigrade, 28 degrees centigrade, so and so. So it is actually dry bulb temperature. What does it mean? Don't worry, my dear students. Dry bulb temperature is nothing but it is the normal temperature of air measured by an ordinary thermometer. And today I am going to do some experiments in this class. I have got a sling psychrometer. Then I have got a thermocouple. And I am going to do some experiments so that you can understand things rather easily. So you should have a physical understanding to this. Now, dry bulb temperature is nothing but let us take a thermometer and you expose that thermometer to air. And please note down that this thermometer is away from solar radiation and moisture content. The air is flowing and the bulb is not covered with anything. Just it is absolutely dry and air is flowing and it is recording the temperature. Let us say the temperature at two different cities, maybe Chennai, maybe Hyderabad. At two places, let us say the temperature is 28 degrees centigrade. This is actually our dry bulb temperature. One second, please. This is actually the dry bulb temperature. What does it mean? It is the temperature of ordinary air, normal air. So now let us assume that at two different places, the dry bulb temperature is 28 degrees centigrade. Let us assume that at two different places, the dry bulb temperature, the temperature recorded by an ordinary thermometer is 28 degrees centigrade. Let us say. Great. Can you tell about the quality of air at two places? Can I say that what do I mean by quality of air? I mean how much moisture is present in that air, which we call it as humidity. In a crude language, I call the moisture present in air as humidity. Forget about relative humidity, absolute humidity. We'll be discussing those things. In a layman's language, I am discussing. Great. Now, if just one temperature is given, that is dry bulb temperature, not much you can infer. That's why one more temperature is required, or rather I would say one more parameter is required to know what exactly is the quality of air, how much humidity is there in that air. Great. So my dear students, if you take a thermometer, this is the thermometer, okay? Now, so air is flowing over this. It is absolutely dry. Nothing is covered with this. And let us say it is recording 28 degrees centigrade. This is your DBT, that is dry bulb temperature. I call it as dry bulb temperature. Now, let us take a thermometer and cover it with a wet cloth. And allow air to flow over this. It will record some temperature. And it is a wet bulb temperature. And I know you have not understood anything, why it is covered with a wet cloth. And one thing is known to me, why it is called as wet bulb temperature, because it is covered with a cotton cloth. Great. Now, have you ever observed, let us say you are in a swimming pool. So after swimming, you come out. Have you ever noticed when you come out from the swimming pool, you feel a bit cold. You start shivering. Okay. Have you observed? If not, now you try to observe whenever you go for swimming. The same thing I will tell you, sirs. Now I have a thermocouple. This is the thermocouple. And look at I kept this this glass with water. I kept this glass with water. I repeat, I kept this glass with water for a long time. So I kept this at 1 p.m. Now it is about 7:30. I kept this water at 1 p.m. So automatically the thermal equilibrium is reached. So whatever the temperature of air is there, the same is the temperature of this. Now if you see the temperature of air, now if you observe, you can see the temperature to be, can you see 24.2? So please note on that. Now I am measuring the temperature of this water. Look at carefully. I am measuring the temperature of this water and it is 24.2. I think you can see 24.2. Okay, no problem. 24.2. Yes, let me show you. So I have, so you can see it very clearly. No problem at all. No problem. Now what I do is, dear students, now you are in the swimming pool. Manlo, this is you. This is you. This wire, this is you. And there is a sensor. Now I am removing this. Look at, I am removing this. You are coming out of the swimming pool. Now you have come out of the swimming pool. Aap aa gaye bahar. Let us see what is the temperature of this. I have come out of the swimming pool. Now I'll show you. Let it take some time. I'll show you because its response is a bit slow. Now you have recorded. I'll remove this. I have removed. Please look at carefully. I'll remove this. I'll remove this from this water. And now you are observing. Please observe. Please observe. Now the temperature started dropping. Now the temperature started dropping. Can you see, sirs? Let me show you. Let me show you. Let me show you. I think you can see. I think you can see. How much is that? 23.7. So earlier it was 24.4 or so. Now it is 23.6. It's dropping. It will come into equilibrium. That means when you have come out of the swimming pool, you started shivering. You started shivering. Same thing when I kept this sensor. Look at, now still it is coming down. Look at, oh my God, 23.2, 20. Earlier it was 24 point something. Now it is dropping. Initially when I kept in water, it was recording the surrounding temperature. That is because that water and surrounding air temperature, it was absolutely same. So you recorded 24.4, something like this. Now it is 23.3. Oh my goodness. So when you come out of the swimming pool, now the temperature started dropping. It is something like, I have removed from the swimming pool. Now the temperature started dropping. That's why when the temperature is dropping, you try to shiver. You feel a bit cold. Now, dear students, let us see the reason for this. And you know, from this thermocouple, you have seen when your body was covered with water when you come out of swimming pool and air absorbs moisture, air absorbs that water from you, and in the process of that evaporation, now it is taking up heat and thereby it is evaporating. That's why you feel cold. That's why the temperature is dropping. Oh my God. Means there must be something with this temperature. So I will try to utilize. There must be something with this temperature. Now I'll try to utilize this. Beautiful, sirs. Ab dekhna, sirs. When the moist air is flowing, when air is flowing over the wet cloth, it's all water. Please observe here. This air is unsaturated. What do we mean by unsaturated? See, it does not contain water vapor to the maximum level. So it has the capacity to absorb some more. That's why the air is absorbing moisture. In the process of absorbing moisture, and you know, these water droplets, they should first be converted into vapor. So thereby, initially they are deriving heat from this wick. This is known as wick. They derive heat from this wick. When they derive heat from this wick, after absorbing heat, now that's why you have seen temperature is falling. It is due to evaporation. It is due to evaporation. Now please understand carefully. So when it is evaporated and that vapor is added to air, that's why due to the evaporation, the temperature is falling. Now I am going to make one video beautifully explaining the thermodynamic process of wet bulb temperature. So I'll be showing you very clearly. Don't worry. In the next video, I'll be showing something like this and how it is coming like this. All those I'll show. But today, let's see the basics. Now, please observe that this moisture this water is getting evaporated. When it evaporates, it is absorbing heat from inside. So thereby, when it is absorbing heat, now the temperature is dropping. That's why you have seen. When I kept it here, when I kept it inside like this, when I kept like this, So therefore, when I removed, now observe, now when I removed, air is absorbing moisture. So when it is absorbing moisture, that heat is required, latent is required to vaporize, and thereby, so that heat is absorbed from inside this, and thereby when it is absorbing, the temperature is coming down, Oh. Now I'll do one experiment, sirs. This temperature under equilibrium conditions is known as wet bulb temperature. Ab dekhna, sirs, we have two thermometers here, 1 and 2. See, one is covered, let me show you very clearly. One is covered with a cotton cloth, this wet wick, and it is saturated. I'll show you. I have poured sufficient water in this. I have poured sufficient water in this. Dekho, I have poured sufficient water in this. Now it is saturated. This wick is saturated. Now what I do is, one is recording dry bulb. There is nothing here. Other is recording wet bulb. So now understand carefully. Now I'll rotate this. If I rotate this, there is a sufficient air movement. So this thermocouple is not giving exact measure, but this is giving the exact measure. Now the air is, when I rotate, there is a air movement, sufficient air movement, and thereby let me make maybe for 30 seconds. Let's see what is happening. The wick which is covered with water, completely saturated with water, the air absorbs that moisture, and thereby in the process of evaporation, observe here, and you know the temperature of this wet cloth, the thermometer covered with wet cloth will come down. Now let me tell you, oh my God. So AC is running here. So therefore now the temperature is, dry bulb temperature is about 24 and the wet bulb is 19 degrees centigrade, around 19 degrees centigrade. You cannot say it, it is 19 degrees centigrade. Now observe, sirs, what physically it is representing. All these details I had explained in my regular plus classes, but now I will tell you something more about this wet bulb temperature. Now, look at, sirs. What I do is, dear students, what I do is, let us take two different situations. I'll take two different situations. Take a second, please. Now, I will take two different situations, situation 1 and situation 2. In both the cases, the dry bulb temperature is, let us say 30 degrees centigrade. Now, let us assume that, 30 degrees centigrade. Let us assume that the wet bulb temperature here is, say, it is 24 degrees centigrade. It will be definitely less. Why? Because when unsaturated air flows over this, what will happen? The water vapor is, is added to air, and due to evaporation from the wick, this is the wick, due to evaporation, the temperature of this will fall, and thereby when it is falling, it is recording a temperature less than this. Now, dear students, if it is already saturated, if the air is already saturated, it is completely full. It has no capacity further to absorb. When it does not, when it has no capacity to absorb, there is no evaporation. When there is no evaporation, there is no heat taken from this. So there is no drop in temperature. So it will automatically indicate the dry bulb temperature. When the dry bulb and wet bulb are same, that means air is saturated. Means air has got full moisture up to the capacity. For example, I'll take two cases. In one case, the dry bulb temperature, in both the cases, the dry bulb temperature is 30. In one case, the wet bulb temperature is 24 and other is 28. What is the physical meaning of this? Let me tell you very clearly. Look at, my dear students. In this case, the difference between dry bulb and wet bulb is large. That is 6 degrees. In this case, the difference between dry bulb and wet bulb is less. It means, why the temperature of wet bulb is very less in this? Because the moisture in air is less. As the moisture in air is less, it has greater capacity to absorb moisture. In the process of absorbing heat, more and more water vapor is absorbed. So in the process of this, it is absorbing more heat from this. When it is absorbing more heat, in order to get converted into vapor, it is absorbing more heat. When it absorbs more heat, the temperature falls. So that's why you are feeling, finding large difference, because the moisture in air is less. When the moisture in air is less, it will absorb more. When it absorbs more, it has to look at, when it absorbs more, there will be more drop, because it absorbs more moisture. When it absorbs, why it is absorbing more moisture? Because water vapor in air is less. In this case, as it is less, it's something like this, my dear students. This is the wet bulb. Now, please look at this is the moisture content. Let us say this is the moisture content. As the moisture content is less, it will absorb this air will absorb more moisture. In the process of absorbing, more heat is taken from this to get converted into vapor. When more heat is taken, there is a more drop in temperature. That's why you are feeling more drop. So please observe, if the difference, we are not actually interested in wet bulb temperature. We are actually interested in the difference between dry bulb and wet bulb temperature. Here the difference is less. It means if this is the wet bulb wick and if this is the air, here the moisture is very large. If the moisture is very large, it has less capacity to absorb. When it has less capacity to absorb, it will take less vapor. When it is absorbing less water vapor, so less amount of heat is taken from this. So when less amount of heat is taken from this, the drop will be less. Thereby, the difference is less. It means when the difference between dry bulb and wet bulb is less, it means air has more moisture. Means it is close to the saturation. See the difference between these two, or just 2. And if this is also 30, means it is saturated. When it is saturated, it has no capacity to absorb. When it has no capacity to absorb, already the saturation is reached. So therefore, equilibrium is reached. So thereby, both temperatures will be absolutely same. Absolutely same. So please note down that if someone asks you, what is wet bulb temperature? It is an indirect indication of moisture content in air. If the wet bulb temperature is very low compared to dry bulb temperature, it means the drop is large. If the drop is large, it has to absorb more moisture. In the process of absorbing more moisture, the large heat is to be taken from in order to get converted into vapor, because the latent heat of vaporization is required. So thereby, when it absorbs more heat, there is a large drop in temperature. So as there is a large drop, so difference when it is large, when the difference between dry bulb and wet bulb is large, it means the moisture in air is less. That's why it is absorbing more moisture. It has more capability to absorb more moisture. When it is absorbing more moisture. So when liquid is to be converted into vapor, there has to be latent heat of vaporization. That's why from the wick it is taking, and thereby the temperature is dropping. So if the difference is becoming large, it means the moisture content in air is less. Okay, now here, as the difference is very small, it means the moisture content in air is sufficient. When it is sufficient, it has ample amount of moisture. So it will absorb less. So when it absorbs less heat is taken. When less heat is taken, there is a less drop. When there is a less drop, the difference is less. The difference is less, my dear students. So please note down that it is the difference between these two is known as wet bulb depression. If the wet bulb depression is 0, means dry bulb and wet bulb is same, means air is saturated. It cannot hold any more amount of moisture. So therefore, please note down that the same thing you can also see in cooling towers. This application. Because in cooling towers, because hot water comes out. And you may be saying, sir, hot water has a thermal energy can be utilized. You cannot use that hot water which is coming out because it is economically not feasible. So I need to cool. So if I want to cool, I'll be using air to cool. So when water is flowing, air will absorb that heat, but it also absorbs moisture. So therefore, air temperature is coming down. So when air temperature is, I repeat, sirs, water is trickled. It's like this in cooling towers. Now, water is sprayed like this. So when water is sprayed, air is flowing. Look at my dear students. If the moisture in air is less, it will absorb moisture, and thereby when it absorbs moisture, what will happen? It has to take heat from this water. So thereby water temperature will come down. But if the moisture content in air is very high, it cannot absorb moisture. If it cannot absorb moisture, the temperature cannot come down. That's why during humid conditions, the cooling tower efficiency will be less, because during humid conditions, already moisture content in air is high. When moisture content in air is high, it cannot absorb moisture from it. When it cannot absorb moisture, there will not be any drop in temperature. You don't get reduction in temperature of water. That's why this wet bulb temperature concept is also used in cooling towers. Wonderful, sirs. Hope you have understood. Now I'll go to a wonderful, please, if someone says, what is wet bulb temperature? It is an indirect indication of moisture in air. If the difference between dry bulb and wet bulb is more, it means the moisture in air is very less. That's why it is absorbing more moisture. When it is absorbing more moisture, it has to take, there has to be latent heat of vaporization. It takes from inside, and thereby the temperature drops. There will be large drop in temperature. And if the moisture content in air is very high, it is close to saturation, thereby the difference in wet bulb and dry bulb will be very less. Wonderful, sirs. Now let us see what exactly is relative humidity. Now I'm going to demonstrate with a beautiful, I have something for you. Dear students, what exactly is relative humidity? Okay, you know, my dear students, at every particular temperature, air has capacity, and please note down that the wet bulb concept I have given in plus classes, and I took just the process to represent the process, why that curve is coming, and I took 75 minutes. So here I am just demonstrating. So now look at what is relative humidity. You know, at every particular temperature, air has certain capacity to absorb moisture. At every particular temperature, air has certain capacity to absorb moisture. So if I increase the temperature, now the volume increases, the gap increases, and thereby the moisture absorbing capacity increases. So the moisture absorbing capacity increases with increasing temperature. So you don't think that the moisture absorbing capacity is constant. No. So if at a particular temperature, the absorbing capacity will be same. Same is the case. You take water and add salt. So up to 1 spoon, 2 spoon, afterwards it reaches saturation, it cannot hold much. But if you are heating the water and adding, it will absorb more. Same is the case. So when you are heating, it expands. When it expands, what will happen? The space increases, and thereby the water vapor holding capacity increases. So at higher temperatures, the holding capacity will be more. Let us assume that please observe that, let this be the maximum moisture absorbing capacity of air at a particular temperature. I am talking about a particular temperature. At one particular temperature, this is the moisture absorbing capacity. Maximum, it can hold up to this. But let us say it is not holding maximum. That maximum we call it as saturation. This glass is showing the maximum moisture absorbing capacity at a particular temperature. So when it is completely full, we say it is saturation. Let us assume that now at this temperature, I have some water. Now let me show. Yes, I have some water. Look at carefully. I'll show you here. I'll show you. Take a second, please. Yes. This is the level of water. If you observe clearly, if you clearly see that at this particular temperature, it can hold up to this full of water for saturation, but it has only this much. So relative humidity shows what is the actual corresponding to, it is relative to saturation. For saturation, it can hold this much, but now it is holding this much. If you see clearly, it may be around 30%. Let us say it is holding around 30%. If you see it, so in this glass we have water up to this, so around 30%. Now just now I told you, as the temperature is increasing, the absorbing capacity is increasing. As the temperature is decreasing, it contracts and thereby the absorbing capacity decreases. I repeat, sirs, as the temperature increases, the absorbing capacity, because it expands and the space is created, more water vapor molecules can be absorbed. So at higher temperatures, the absorbing capacity will be more. And if I decrease the temperature, it shrinks and thereby the space is less and thereby absorbing capacity will decrease. Now, dear students, if you have observed the psychrometric chart, it is something like this. Anyway, if you attend my regular plus classes, I'll be explaining why this chart is obtained, how it is obtained. I'll be telling you how this chart is coming. Here I take omega, which is the actual mass of vapor to the mass of dry air or partial pressure of vapor. On this axis, you take dry bulb temperature, and this is the saturation curve where the relative humidity is 100%. Now, let us assume that. So please tell me, is it saturated? No. So let us say here the relative humidity is 100%. Now I have taken, in our case, let us say it is 30%. And say the dry bulb temperature is some 30 degrees centigrade. So at 30 degrees centigrade, and this is the relative humidity, let us say, this is my point. So actually, what is the relative humidity here? Anyone? Around 30. The maximum capacity is this much, but it has only this much. It has only this much. It has only this much. So let us say it is 30%. This line is corresponding to 30% relative humidity. This is relative humidity 30%. And this is the dry bulb temperature. This is the point. Now, please note down that the actual water vapor which is present, the actual water vapor, we call it as absolute humidity or specific humidity. This is the actual water vapor. This is the actual water vapor. Now, what I do is, I will cool this. This is the absorbing capacity. This is the absorbing capacity or saturation, full glass saturation conditions at this temperature. Now I'll reduce the temperature. If I reduce the temperature, what will happen to the absorbing capacity? If I reduce the temperature, what will happen to the absorbing capacity? It comes closer, they come closer, space is less, and the absorbing capacity decreases. So this is showing, the full glass is showing absorbing capacity at this 30 degrees centigrade. So which I have shown by this point. Now let us reduce the temperature. But are you changing the moisture content? No. Whatever moisture is there in glass, I'm not changing. When moisture is not changing, means it should be horizontal. Omega is not changing. So therefore, temperature is decreasing. Look at, when the temperature is decreasing, let us say we are here. Oh my God. You tell me what has happened. I have decreased the temperature from say 30 to 25. Let us cool it. Now I have reached this. You tell me what is happening. Now the relative humidity, we are coming to the saturation. Physically, I'll explain now. Let us say it is 70%. How? Dekho, this is the 30% relative humidity at this temperature. Now, I'll reduce the temperature. When I reduce the temperature, what will happen to the absorbing capacity? It decreases. This full glass is showing absorbing capacity at 30 degrees centigrade. Now, you tell me at 25 degrees, what is happening to the absorbing capacity? It decreases. Means now it is no more full glass, it is becoming less. So therefore, now at 20 degrees centigrade, at 25 degrees centigrade, the absorbing capacity is decreasing. Now I am cutting this. Dekho, the absorbing capacity is decreasing. Look at carefully. The absorbing capacity is decreasing. Dear students, the absorbing capacity is decreasing. Dekho. Yes. Now, originally, this was showing absorbing capacity at 30. It was more. So when the temperature is reduced, the actual mass is not changing. But as the temperature is decreasing, absorbing capacity is decreasing. Now you tell me what is the relative humidity. Originally it was this by this total. So it was less. Now it is this by only this. So that's why the relative humidity is decreasing, my dear students. We are moving towards saturation. Now let us further decrease the temperature. So I will reach this point. I don't know what is this point called as. I will reach this point. We have reached saturation. Now it means I will further cut down this. Ida dekho. Now I will, because when the temperature is decreasing, the absorbing capacity is decreasing. So when the absorbing capacity is decreasing, look at. Thoda bear karo sirs, please. The absorbing capacity is decreasing. Now let me cut. As the temperature is now, let us say it is, now as the temperature is now, let us say, kya le lenge? As the temperature is, let us say, some 20 degrees centigrade, it has reached saturation. Now you see, at 20 degrees centigrade, listen my dear students, at 20 degrees, at 20 degrees centigrade, this is the absorbing capacity. Now it has that much water. It is at 20 degrees centigrade, this is the absorbing capacity, and exactly it has that much water, that much vapor. So means it has reached saturation. And that particular temperature, we call it as dew point temperature. At a constant pressure, when you are cooling, and that particular temperature, you call it as dew point. So let us say this is 20 degree and this is the dew point temperature. Now I will cool it further. Ab dekhna sirs. If I cool it further, what is happening to the absorbing capacity? Decreases. When it decreases, water will come out. Condensation. When I cool it further, when I further decrease the temperature, water will come out. Idhar dekho. Now, idhar dekhna re. Dekho. I'll cool it for, idhar dekhna. I'll cut it further. Oh! Rain. This is the concept. So, when it reaches dew point temperature and further it is cooled, condensation will take place. So when it reaches dew point, further it is cooled, water is decreasing. Now thereby, water is decreasing. Now there is a condensation. Therefore, now This is the concept of relative humidity. What is the concept of relative humidity, my dear students? It is the absorbing capacity. It is the absorbing capacity at particular temperature. If I increase, the absorbing capacity is increasing. If I decrease, the absorbing capacity is decreasing. So hope you have understood. And in the next class, I will give you some more beautiful concepts with models. Thank you. God bless you all. Thank you.